Good morning, everyone. Welcome to COVE's Naval Innovation Technical Challenges. If I can get started here, I just want to let everyone know that the webinar is being recorded today. And so we are very excited to present, as I said, COVE's Naval Technology Innovation Challenges. Here today at the webinar, we are partnered with Thales Canada and COA. This year, both the challenges are focused on solutions that reduce the impact on environment and promote greater sustainability. So with me today, we have Dave Peterson, Naval Architect on Aegis. Dave, if you can unmute yourself and just say hello so I can see your face.
Sure. Good morning, everybody. Thanks for attending the webinar. And
Great.
Thanks for having me here, James.
Yep. So Dave's going to be introducing the first challenge, capturing maritime greenhouse gases. And we also have Michael Chasen, ship maintenance lead, who is going to be introducing challenge 2. Michael, can you say hello?
Yeah, good morning, everybody. Thanks for joining the webinar this morning, and thanks, James, for the invite. Happy to be here.
Great. So first today, I'm going to introduce the challenge concept, and then we're going to have Dave and Michael introduce the challenges in a bit more detail. And then finally, I'm going to go a bit through the process of applying eligibility, things like that at the end, and we'll open it for questions. If you have questions throughout, feel free to drop them into the Q&A box. The chat box, I believe, is disabled, so Q&A box is where you want to go. And if you would like to speak up at the end, there'll be time to ask questions directly. The Thales guys are going to stick around for that as well. So after last year's success, with the challenge program, we are so pleased to introduce 2 new and exciting funded challenges, again, partnered with Thales and COA. Through these challenges, Thales is looking to extend its leadership role in the Arctic offshore patrol ships and joint support ships in-service support program, also known as Aegis. To do this, Thales is coming to the unique expertise and speed of the startups and SMEs that we have here in our ecosystem in the Atlantic region. And ultimately, Thales wants to accelerate the Aegis innovation roadmap by proposing what are the resulting solutions as a change proposal to the RCN, if applicable. So we're so excited to be here to partner with Thales and COA and offer these innovation challenges and help identify Canadian SMEs that can help develop, test, and hopefully deploy their solutions to the benefit of Canada. So I'm going to go just at very high level over what these challenges are for anyone who isn't familiar already. So companies, organizations are going to apply to solve specific technical challenges that are related to the Aegis program. Aegis includes in-service support, retrofit, repair, maintenance, training for the Royal Canadian Navy's new AOPS and JSS vessels, and this is the largest in-service support contract in Canadian history. The companies that are selected will be awarded $175,000, which is funded by Thales Canada and COA. The solutions there must be some level of innovation that is completed in the development of these solutions. So nothing that is off the shelf ready to go. And the companies are going to retain any of the IP that's generated with these solutions. And a license will be issued to Thales for their use. So the first challenge calls for innovative solutions that could be used in capturing maritime greenhouse gases on naval ships. The second aims to innovate technologies that can automate the cleaning of onboard air ventilation systems to increase ships' air quality. And so I'm going to hand it over now to Dave Peterson to speak a little bit more in detail on capturing maritime greenhouse gases. Dave, over to you.
Howdy. So thanks again for having me. My name is Dave Peterson. I'm a naval architect with Thales. I work on the Aegis program, which looks after the AOPS, the Arctic Offshore Patrol Ship, and the JSS, the joint support ship that'll be coming starting next year. What this challenge is really focused on finding some innovative technologies to reduce the greenhouse gas footprint of the ships in the Aegis program. As you know, AOPS was made to allow the RCN to have presence in Arctic areas. Those are sensitive ecosystems, to be sure. And this is a way of hopefully reducing the footprint of these ships in those areas, or well, globally, right? Ships provide about 3% of the overall greenhouse gas emissions. That's all shipping in the world. So there is an actual opportunity to leverage these technologies to make a significant impact. So on that, we're looking to develop an innovative solution for capturing GHGs on naval ships. Ideally, we'd start with the AOPS, and if we can prove a technology, we can certainly leverage that to the whole Royal Canadian Navy, and look at making an impact that way. This would be supporting the Department of National Defense New Climate and Sustainability Strategy, which, it's a mission for all of us to reduce our GHGs. Next slide, James. So the requirements. Solution must capture greenhouse gas emissions, primarily CO2, but it would be really good if we can capture CO and nitrous oxide as well. Those particular gases have although they have a shorter life in the atmosphere, they have a bigger impact than CO2. Stored captured CO2 securely on board. So we not only need to capture it, but then we need to store it so that we can offload it safely once we're in a port. Alongside. We want to be able to quantify the performance of it, right? So we need to know how much greenhouse gas we're removing from it. This is the last point is the hardest point. Be feasibly installed and maintained on naval vessels, right? So this is a challenge where we're taking weight and we're putting it up high. So as a naval architect, that's the last thing I want to do. But it's that speaks to the very technical challenge behind this is how do you do that efficiently and integrate it within a ship and store all of that material so that you can then offload it later on. Next slide. Some considerations. All right, a practical demonstration at a shore-based test location will be required to close out the project. And that's, there's going to be some flexibility with that because, it won't be at a level where we can actually put it on AOPS by the end of this project, but we need to be able to demonstrate it and prove it. So we're looking for a technology with a TRL of at least 5. We want to mitigate the potential burden on ship staff for additional manual tasks or to in-service support contractors. So obviously we know there is some in-service support that's going to be required by this, and there will be some impacts to staff, but we really want to minimize the amount of that. So we're looking for novel, innovative ideas to support the actual in-service of it as well as the operation of it. Ideally, a cost neutral on fuel consumption, and that is a challenge with scrubber systems for GHGs. Is sometimes they can burn more fuel or extra fuel in order to provide the same value. Demonstrate awareness of government security clearance requirements and associated timelines. Right. So we, obviously with this project, we're going to need to transfer some of the data for the ships to the incumbent challenger. And we just need to make sure that we are handling and managing that data within the requirements of the government of Canada. Next slide.
Yeah, that's great. Yeah, thank you very much, Dave. Really good to hear from your perspective, the value that this can bring and some of the key points that people have to put in their applications. So up next, we have Michael Chasen, who's going to be speaking to a bit more detail on the Clean Air in Ships Challenge. Michael.
Awesome. Thanks, James. Good morning, everybody. A little bit of background. So my name is Michael Chesson. I'm a ship maintenance lead for the Aegis program. So I'm a ship manager for the AOPVs. So essentially, I plan, coordinate, and then execute all the short work periods that the boats go through when they're alongside, which involves a heavy amount of preventative maintenance, especially in the HVAC systems. My background, I spent 12 years in the Navy. I've operated and deployed on the frigates, on the maritime coastal defense vessels, and the AOPVs themselves. So I can personally speak to how important it is to maintain the quality of air throughout the ships, especially when they're going up north and down south, going all overseas. We want to make sure that we mitigate the amount of dirt, grime, and mold that are in the ship. So the challenge number 2, clean air in ships. We're looking for innovative tools that can be applied in the marine environment to automate the cleaning of air ventilation systems and improve air quality on ships. So all of the HVAC systems on board, they do have preventative maintenance routines that get conducted every time the ships are alongside, as well as at sea by ship staff to a certain extent. What we're looking for here is an innovative way to reduce the amount of manual labor required by the contractors and by ship staff by injecting something extra above and beyond the preventative maintenance routines that we currently see. Next slide, James. The requirements for this challenge, we're looking for continuously or in real time identify the presence of mold or other contaminants when they are first present in the ship's air systems. Ships do currently have systems in place, but what we're looking for is something that's more accurate and something that's more repetitive or real time, that we can pick up and find the mold before we send contractors to go actually see it. We're looking for technologies that can clean through the most challenging stretches of ventilation duct systems on the ships. So on the AOPS, we have air conditioning plants spread throughout the ship, all the way from 1 deck all the way up to 04 deck. But we have what I could only assume is kilometers worth of ductwork that are hidden behind false bulkheads and false deck heads. So we'd be looking for some sort of technology that can be employed without having to remove all of those false structures to reduce the amount of time required. And lastly, we're looking for solutions that continually quantify both the presence and removal of mold in a user-friendly manner. So not only do we want to see how much mold is happening in these ships, but how much we're able to remove from this system. So it's really critical for us in this challenge to be able to identify that if what we're currently doing is not enough, what can we employ to ensure that the sailors on board are breathing clean air at all times. Challenge 2 considerations. So there's a couple things that we're looking for here. So the solution must be demonstrated at the close of the project to improve the air quality in the ships for the practical benefit of the sailors' health. We need to be able to see with our data that the before and after, that there's a noticeable difference that can be tangible to the human health. We're looking to explore technologies that can be installed within ventilation ducts to clean the air and surfaces continuously. So I think what we're looking for here, we're looking for a variety of solutions, and we're very open-ended to what you could propose. But the ideal situation will be something that can be installed and then just continuously run. We're looking for easy installation and minimal disruption to the ship's operations. So a critical thing here for the AOPS is, like I said, there's false deckheads and false bulkheads. So there is quite a bit of work required to remove those. So we're looking for something that's going to be easy to install and not impact ship from their day-to-day activities. We're looking for non-invasive techniques. And we're trying to demonstrate awareness of the government security clearance requirements and associated timelines of the exchange of engineering data, very similar to what David talked about earlier. So we're just looking to make sure that we can employ this in a way that meets all the requirements set out by the government.
Thank you, Michael.
Thanks very much, James.
Yeah, of course. The people who I ran this challenge past that have been on ships were very excited to see that it was being tackled, and we're hopeful that it would be successful. So I'm going to speak a little bit more now about the selection process. Thanks a lot, Michael, and sort of who is eligible to apply and how you go about doing that. So first off, very similarly to last year, companies will be submitting applications through the COVE website, so coveocean.com/challenges. There's a QR code there if you'd like, and if there's any questions, before submitting your application, please do so through the challenges@coveocean.com website. Feel free to reach out to me on the side as well if you'd like. We also have a requirement this year for companies that must be incorporated in Atlantic Canada. And so if there's a company that is willing to partner with companies on a submission, let me know through that email there, and we can put you in a roster of companies that put their hand up and say I'm willing to do a joint application. So who is eligible to apply? The program is open to startups and SMEs. So this is looking at companies with less than 500 people and less than $50 million in revenue. This is open to commercial and non-commercial organizations incorporated in Atlantic Canada. Federally incorporated companies can participate in the challenge if they're registered to do business in the Atlantic region, but these companies must have a significant operation, such as facilities, offices in one of the 4 Atlantic provinces. And so companies that can apply on their own would be small and medium-sized businesses, as well as Indigenous organizations and groups that fall under that incorporation we just talked about. Organizations such as post-secondary institutions, other for-profit and not-for-profit organizations may apply, but they have to do so with a group as a joint application. And so the proposed solutions must not currently be available on the market. We kind of talked about that a little bit throughout this webinar so far. There is innovation that's required as part of the solution, so we're looking to generate some IP here, ideally. Okay, so selection panels, we will, there's a slide there, didn't I? No, I didn't. So for each challenge, there's going to be a diverse sort of selection panel made up of a Thales representative, an Aegis representative, COVE representative. We'll have an ITA from NRC, an independent industry expert, as well as ACOA will have a seat on the panel as well. And each panel will be looking at the applications separately. What are they going to be assessing? So we're looking at 6 different areas for the applications, and if anyone's already looked through the application, you'll see this kind of lines up with the questions that have to be submitted on. They're each weighted depending on their importance. So most important factor here is the solution fit. Does the solution address the problem statement? That's the most important piece of this whole thing. What is the impact this award will have on the company, and that if the solution is successful, what is the impact it will have on the local economy and the environment as well. The next piece is the expertise of the people who are being put forward on to work on the solution. So what is the background of these people, and sort of tied to that is the resources that are going to be made available. So do you have the resources available given your current workload to address this challenge and really come up with a viable solution by the end of the timeline? What is the level of innovations that's required? So, are we starting at a TRL 5? Are we starting at TRL 6? And what is going to be required to get you to a point where we can demonstrate this to Thales? And is this, for timeline, is this viable to do in sort of a 6-month timeline? So I think, speaking about the timeline, we're already open. So applications are open now. They opened earlier in March. They will close April 14th. And so make sure that you get your applications in before April 14th. We'll then be doing a couple of weeks of submissions or evaluation of the submissions with the judges, followed by some time for contract development with whoever is selected. And that gives us time to go back and forth, assuming that we find the right companies and everything lines up with incorporation and everything, we can proceed in that timeline. And then we'll be announcing the winners at the H2O conference June 4th, which is quite exciting, and we'll begin the implementation and solution development sort of the next week, going on we put a minimum of monthly project meetings, but last year kind of happened on a weekly and bi-weekly basis, as there was a lot, during there's a lot more technical requirements that needed to be ironed out in the early stage of the project versus later stage of the project. And so that'll happen ad hoc as needed. So in that 6-month period, there are project milestones that will have to be met for payments to go out. Through the challenges, the partners are working to increase capabilities in the Atlantic region. And so the research and development and the projects must take place in one of the 4 Atlantic provinces. And that's across the 4 milestones here. So the first milestone, obviously, being both challenge winners are selected, and we've completed our kickoff meeting with all of the parties, and everyone's sort of on the same page. The second milestone being a submission of a preliminary design that has been reviewed and approved, and this should include an implementation plan of how this would get rolled out eventually. The third milestone being a detailed design review, so looking at the sort of more detailed look at the solution, and then what is the testing plan for the team. Finally, the solution should be delivered, tested, and accepted as meeting all project requirements, and that has to be approved by the Thales side, from the Thales side and the COVE side as well. And then we'll sort of proceed, and that all has to be completed by December of this year. So that's really at a high level what we wanted to talk about today. It's so great to see this partnership continue to evolve as we collaborate and work towards generating greater value and innovation and sustainability across the sector. And this is a real opportunity for innovators to throw themselves at a problem area while getting direct interface with experts and the customer, and having the funding to really tackle these problems. So it's quite exciting for us to see. I'll just say again, if you're looking to submit an application, please do so through coveocean.com/challenges. And if your company, maybe this is not an applicable challenge for you, please forward this on to someone who you think this might be an applicable challenge for. We're really keen to see the innovative solutions and the applications come through. And I just want to extend another thanks to Thales and ECOA, and open up the floor for any questions. So please, if there's questions through the chat or the Q&A box here, we can do those. And if you'd like to speak up, raise your hand. I believe there's a raise hand function, and we can unmute you. So I'll go to the first question here, which looks like there's some answers on as well, but maybe Dave, I'll have you just so everyone can hear the answer. The first question, for the GHG sustainability element, are there specific targets being looked at, such as IMO, Government of Canada, some other source, or are we looking at as low as we can go?
Yeah, so excellent question, Al. Right now, we haven't identified any targets that we want to achieve. Having said that, to your point, that going as low as we can go is a good novel target. What'll really prove the value, though, is identifying and quantifying how much actual GHG removal does it do, and that is that'll identify, is the juice worth the squeeze? If it only skims a very fine layer, then it's may not be a value relative to the cost of implementation and actually putting it on the ship. So excellent question. We don't want to frame it in with a particular target just yet, but we do want to quantify and identify the amount of greenhouse gas removal that it does.
Great, thank you. I don't think there's any other questions through the question area there. So unless there's someone else who wants to raise their hand or submit a question, we'll maybe leave a couple minutes here. And as I said, if you're a company who would like to apply, please do so through the website. If you know of a company this might be applicable to, please forward it to them. And we would be happy to answer any questions through the challenges at coveocean.com email address. If you'd like to put your hand up as an Atlantic Canadian company that is willing to partner with a company from another province, for instance, please let us know as well. And we'll go from there. So I'm just going to leave. I'm going to stay here for a couple minutes, and if any questions come through, we will we'll answer them. Otherwise, we'll close out the webinar for the day. Thank you very much for attending, everyone. Oh, we have another question. Alan, would you like? We'll unmute you here. We're trying. Yeah, I think he's muted now.
For some reason, Zoom doesn't actually give me an unmute, but that's okay. Why would we need a button? Yeah, no, I was curious on when we look at the net zero, could that net zero be largely sort of a closed loop process, i.e. the process that's being used to reduce the GHGs or the CO or the nitrous oxide, would that be running sort of inside its own sort of system, or could you count, let's say, an emission of that process that might be useful to another aspect of a ship towards the contribution of a net zero? So, for example, one of the processes that we're looking at actually has methanol as a byproduct, which has a number of different uses. But
Al, we're open to your innovative ideas.
Okay. So make sure it's written down and make sure it works.
Absolutely. Yeah.
Sure that.
I don't want to apply too many guardrails. If there are excellent byproducts as a result of the process, that's worthwhile evaluating as well. So go forth and innovate.
Yeah. Roger that.
Okay. Yeah, part of this process, we're not doing an RFP here. The idea is to see what the innovative ideas are and pursue them, get a real road out of them. So yeah, that answer your question?
Oh, it does, and I'm really glad it's not an RFP.
Great. Thank you. All right. Well, I think if there was another question, it probably would have come up by now. So we'll just go ahead and close out the session here. Again, feel free to reach out to me at my emails, james.keston@coveocean.com, or the email you see on the screen in front of you. And I guess there's one final slide here. So head to the website, and all of the information is up there as well. We are going to be posting this webinar to the website. So yeah, you'll be able to watch it there again if you missed anything along the way. Thanks very much, everyone. Have a great day.